chaps, so this video I'm going to make just about proving a bunch of the rules that I gave you in the last lesson. As far as I can see from what the book says, I don't think you're required to understand it, but I think it's quite important, you know, come on, we're AB Maths, we really want to open our mind. So let's start with this. Yeah, go on, let's do that. So let's say we have f of x equal 4, a horizontal function. We said that the derivative is 0. And we based it on the fact that the line is horizontal, so there's no gradient, okay? So therefore it has to be 0. But I want to just use the definition to kind of really prove it. So derivative of x, okay, is the limit where h approaches 0, where f of, I'm not going to write it again, okay? It's, you know, let's look at the derivative at a specific point, okay? X plus h, okay? What will be the function? What will be the y value of the function? Well, the answer will be it's 4, okay? It's 4, okay? And I need to minus the value of the function at the point x, which is very close to it, which is also 4. And we divide it by h. Okay? Now this is one thing I remember as a student, made me really think and also a bit frustrated sometimes. What do we get there? We get, okay, limit h approaches 0 equals 0 over h. Now, what is 0 over h where h approaches 0? What does that mean? Well, h is as close to 0 as possible, but not 0. You understand what I'm saying? It's as close to 0 as possible, but it's not 0. So 0 divided by h, 0 divided by this tiniest number you can think of, but not 0, is 0. Okay? I know it was a little bit, you know, as a kid I remember thinking about that, but I guess I just came to terms with it, right? 0 divided by h, doesn't matter how close h to 0, it's not 0, so that's equal to 0. Right, let's move on. Okay, the second thing I want to prove you is this very useful rule that if you have a function, okay, y equals constant times x to the power of n, the derivative of that function will be the exponent times the constant times x to the power of n minus 1. We're taking the exponent 1 down. Okay? How do we prove that? Extremely useful to use, and I hope you did the exercise that I need to do first of all to just get used to that rule, and now let's prove it. And again, you don't need to know it, but let's know it. Okay? Right, so dy to dx, we're going to take the limit of the difference between the function, value of function in x plus h minus f of x divided by h. Now, what is f of x plus h? Okay, we're going to substitute x plus h in the value of the function, not this. We're going to try and prove that. So it's going to be a x plus h to the power of n. Okay, that's the value of the function of x plus h at x plus h minus the value of the function at x divided by h. Okay. Now what we've got here, we've got x plus h. It's a polynomial. X plus h power n. N could be 3, 4, 5. Okay. Now what I need to do now is expand it. Okay. Let's have a look. What is x plus h power n? It's x plus h times x plus h times x plus h n time. Now, if I was to open it, okay, what will I get? Okay? Well, I'm going to get a whole bunch of, a lot of different kind of components, okay? And I don't actually need all of them, but I need a couple of them, okay? Now, what I'm going to do now is something so important that happens again and again in maths when you go to university, so it's worthwhile just having a look at it. What are we going to do? We're going to x times x times x, okay? I'm going to power times x by itself. How many times, okay? Because I had this thing is happening n times, right? I've got x plus h timing by itself x times, m times. So I'm going to have x power n. The next thing I'm going to have is, let's start with h times x 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 times x, okay? H times x times x times x times x times x, okay? So it's going to be h times x by itself. Okay? How many times it's going to be time by itself? Not n times, because for the first one I used an h, so it's going to be n minus 1. Okay? Now, so I'm getting a polynomial here. The highest degree is x power n, the second one is x power minus 1. And for now, I think that the constant is just h, because I did h times x times x times x times x. But then I've got another one of those. Look at this. If I decided to time this x by that h, and then by x by x by x by x by x by x, I'm also going to get h times x power n minus 1. Okay? And then I can actually do something else. I can multiply this x by this x, and then time it by that h, and then by x by x by x. Again, I'm going to get hx times x power minus 1. Okay? And you can understand, I can do it for each one of these brackets. So I'm going to have a bunch of x to the power of n minus 1 every time multiplied by h, and I'll get quite a few of them. How many of them? How many factors would I get with the x to the power of n minus 1? Well, I'm going to get one when I choose that h. I'm going to get the second one when I choose this h. The third one will be that h. So how many exponents, how many factors with x power minus n minus 1? Okay? M times. I'm going to have n choices to choose. It's basically a probability question, counting question. How many factors will I have with x power n minus 1? Well, I've got m h's to choose from, so I'm going to have m of those. So it's going to be mh x to the power of n minus 1. Now the next one, okay, if you ever done binomial theory, which I don't think you've done, okay, binomial theory, then you'll understand that. Now I don't think you've done it, but you might come across that next year when you're going to do, what do you call them, the like part of your portfolio, you have to do a few investigations. Got their name for it. There's a short one, a long one. You will be doing that in grade 12, and often we teachers choose to do some investigation of binomial theory. Then you'll come across it again. Anyway, the next polynomial will also be x to the power of something, okay? But it will be lower than n minus 1, okay? Okay? It will be, let's say I choose this h, so I multiply h times x times x times x times x times x times x, okay? So in this case, the x will be to the power of n minus 2. But now I have h times h. So I have h squared. H squared. Now, I'm going to have a bunch of these factors, okay? Because I can start with h times all the x's, or I can do h times x times h times x times x. So I'm going to have a whole bunch of those. And in this case, I don't even care how many I have. Okay, I've got some kind of number here. Let's call it C1. Okay? C1. It's a constant. Okay? Then the next one, you won't be surprised, is going to be x to the power of n. And we'll give it, x to the power of n minus 3. Okay, so you can see it's always going down. And now I'm going to have h cubed, okay, because I chose 3 h's. H times h times h. Times x times x times x times x, and there will be another constant here. Again, I don't care about it, we'll just call it C2. And it will carry on, carry on, carry on. And what you notice here, then you will come across that in a proper investigation of binomial theorem, that as the exponent of the n's goes down, n minus 1, n minus 2, n minus 3, the exponent of the h goes up. So here I don't even have h, right? I don't have h. If I don't have h, it's like I'm doing h power 0. Okay? So here I have h power 0, here I have h power 1, here I have h squared, here I have h3. So if you add those together, m plus 0 is n. n minus 1 plus 1 is 0, n is n. n minus 2 plus 2 is n. n minus 3 plus 3 is n. Okay, so I'm going to get rid of that, I don't need that. Okay, so you can see some kind of pattern here. Okay, what will be the last term? The last term will simply be h times h times h times h. So it's just going to be h power n. With no x's and no numbers, because it's just one of them. Okay? So this is this whole thing. Okay? If I expand x to the power x plus h power n, I'm going to get x to the power of n plus nh m minus 1 plus a constant h squared times x m minus 2 and so on and so on and so on and so on and so on. Now what I've got to do is copy that up to here. Okay? Should have given a little bit more space. I'm just going to erase that. Hopefully I'll remember. You'll remind me, right? If I forget, you tell me, you'll shout out. Okay? What number I need to put here. Okay. So we're going to write equal in the limit h approaches 0. Okay? We're going to write a. Okay? And now I need to expand it. I'll put the little brackets here. I'm going to write, okay, I've got x to the power n plus m h x to the power m minus 1 plus c1 constant h squared m x m minus 2 plus c2 h cubed x m minus 3 plus so on. I didn't write all the terms. You'll see later on it doesn't really matter. Okay? The last term is h r n. Okay? All that. This thing is just that. Then I need to take away a x power n divided by h. Okay? Now, let's have a look what's happening here. I'm going to write down limit h approaches 0. Okay. Now, I need to really open. I need to time each one of these by a. Shall I do that? Just let's do that, okay? So I'm going to time that by a. I'm going to time that by a. I can time that by a. Might as well do that. Time everything by a. Everything by a. Okay? And then I'll get rid of that. Okay. Now, get my red pen. Okay? And you can see ax power m cancel out. Okay? So I have a m h x power m minus 1 plus a c1 h squared x m minus 2 plus a c2. I'm going to even not write that one. I'm just going to say dot 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 dot. It has an h there. Up to a h n. You'll see why I don't actually even need to write that. And you'll see it in a second. Okay? But it's there. The fact I'm not writing it, it's not there. It's there. You'll see it. Just in the dot dot there. Divide by h. Okay, okay. Now, what I'm going to do, you can see that there's an h here, there's an h square here, there's going to be an h cube, h power 4, h power 5, up till h power m there. So what I'm going to write now, I take h out as a factor. Okay? I'm going to write h, a n x to the power minus 1 plus a c1 h. Okay, I leave it 1 h times h is h squared. X to the power minus 2 plus. The last one is a h m minus 1 divided by h. Red pen, h. Remember, this is what we did in all our kind of definition, kind of quick calculation. We want to get rid of the h in the bottom. We didn't want to have that h approaches 0 at the bottom. As soon as I got rid of it, what can I do? I can just substitute h equals 0. Once I got rid of it, now I can say, okay, h approaches 0. We'll put it as equal to 0. So I'm going to have h equals 0 here. Okay, I'm going to make it equal 0. I'm going to have, everywhere here, there's h. The next one will be h squared. The next one will be h cubed. Okay, h power 4. The last one will be h power n minus 1. But they're all equal to 0. They are all equal to 0. In other words, they did. Okay? All these terms, okay, the dot, 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 including those two, are all did. And the only surviving term is the one that didn't have the h. And that's that one. Okay? Originally it had that h. It had that h. But now when I took the factor h out, it got cancelled with that h. So the only surviving term I have is a n x to the power n minus 1. And look at this. Magic. Okay? That's what I want to prove, isn't it? I want to prove the derivative of y is ma. Okay, I wrote ma. I got a. It's the same thing. X to the power n minus 1. So, voila, magic. Okay? We managed to prove where is this coming from. Okay? Now I'm going to pause here and I'm going to prove you the third rule, the next bit. hang on there. Okay, the last part in this really heavy lesson, this is a heavy lesson, okay? We're doing like proper, I guess, university level maths, okay? We're proving things, okay? University maths is about proving, not so much about calculating, okay? But I think it's important. I think I want you to be exposed to it already, okay? So the rule was that if we have a function, let's say h, which is a sum of two functions, f and g, okay? Then the derivative of h is going to be the derivative of f plus the derivative of g. Just to give you an example, let's say h of x is equal to 3x power 2 plus 2 over 3x power 4. Okay? So if I want to do the derivative of h, what I've got to do is do the derivative of this, okay, which is 6x, plus the derivative of that, which is minus 4 times 2 over 3 x to the power minus 4, 5. Okay, you can have a look later why I've done it, but the idea is that you do the derivative of that, and you add them together. Now, I think it's one of these rules where you say, oh, no, it kind of makes sense, okay? Makes sense is good, it's really important, but that's not enough in maths. In maths, we need to prove it, okay? So, okay, even in AP maths, we didn't really need to prove it, but you got actually the tools. You have the tools to prove it. So I personally, I'll be honest with you, I gave, not even AP, but last year in grade 12 where I taught, and in one of the tests, I asked to prove that. So I asked to prove that. Yeah, I don't think anyone got it, but it went past the teachers and they were happy for me to do it. It's kind of a thinking question. It's not something we come across in textbook, but it is something that in theory we have, because we have the tools. What are the tools? Simple, just the definition. It all comes back from the definition. Derivative of function is the limit of the difference between f of x plus h and f of x, and divided by h when h approaches 0. So that's our starting point. So what I'm going to do to find out the derivative of h, I'm going to say, okay, it's the limit where limit of, okay, I've got a little problem. I've got two h's. Okay, I've got the h of the function and I've got the h of the h. So let's just, instead of h, we'll use, I don't know what. What do you want to use? I. Let's use I. Okay. So it's going to be the limit of h approaches 0. Okay. I x plus h minus I x divided by h. Okay. That's our starting point. Just putting out, it's the value of the function x plus h minus the value of the function of x divided by h. Okay. Now we need to spell it out. What is the value of I in x plus h? Well, everywhere where there's x, we put x plus h. So it's simply, never forgetting the limits, okay? It's simply f of x plus h, because that's what I of x is. I of x plus h is f of x plus h plus g of x plus h. Okay? I'm just putting, instead of x, I'm putting x plus h. Now I need to minus, okay? And let's just make some space here. We're going to put the value of I of x, so it's minus f of x plus g of x. And I'm careful to put it in brackets because I've got minus. Dividing by h. Equal limit h approaches 0. Okay, now what I'm going to write. Look, I'm just going to open it up. Okay, it's going to say f plus x plus h. Now, if you don't mind, I'm going to swap these. So it's supposed to be plus g of x plus h minus f of x minus g of x. But I'm going to swap these two together. So it's going to be minus x f of x plus g of x plus h minus g of x. Okay? All I did is just swap these two together. Okay? Divide by h. Now, what can I do now? What I'm going to do now, I'm going to split that into two fractions. Okay? So that's going to be equal to the limit. H approaches 0. Okay? I'm going to do f of x plus h minus f of x divided by, okay, we'll just do it like that. No. Divided by h plus, okay, so I did those two divided by h, and now I'll do those two divided by h, okay? So g of x plus h minus g of x divided by h. Okay? Now, that is all like that. Now all I can do is, okay, you want to take the limits, you're going to take these two fractions, the limit where h approaches 0. What I'm going to just write is just write the limit for each one of them, okay? So I'm going to say, okay, it's the limit where h approaches 0, f of x plus h minus f of x divided by h plus the limit h approaches 0. I could have done it straight away, okay, because I've got two fractions, separate fraction now, okay? X plus, there's a plus the h here, minus g of x divided by h. Okay, okay. What do I get from this? Ma nafka mina, you say in Aramaic. Ma nafka mina. What is that? F of x plus h minus f divided by h in the limit where h approaches 0. Well, that's exactly the definition of the derivative of f. Okay? So this one is simply f of h, f of x. The derivative of f at point f, in point x. And this, equally, the same way, is derivative of g. Okay, because I have a difference in the g values divided by the h. Okay, so that g of x, that's what I want to prove, isn't it? Okay, alright, I'll prove that the derivative of, that should have been I, not h. The derivative of I is simply the sum of the derivative of f and g. And notice that in this whole process, I didn't say what f and g was. I didn't say that f is 2x cubed or 3x squared or sine or whatever. I just called them general f. F can be anything. G can be anything. So I proved the general rule. Okay. See you guys next week.